Hello everyone, welcome back to the channel. So here we are with our fourth and the final part of Matter in Our Surroundings series, which is the first chapter of class 9. So before even I begin, I would like to give a big thank you to all those people who've been coming to my channel and looking at all my videos and been learning from it. It really boosts me a lot to make more and more videos. So I'm really grateful. Thank you so much. So let's continue learning and we'll be finishing up the chapter in this video. Alright, so topic for today will be effect of change of temperature. In the earlier videos we've learned about different states of matter, which was the last video. You can find the link below for the previous ones. So effect of change of temperature is here. So we'll be understanding two cases here. First will be when the temperature is risen, when we increase the temperature, and the second case will be when we decrease the temperature. So the first case is when we increase the temperature. Increasing temperature, and also we will be doing it in the form of different states of matter as well. So case 1 part 1 is about solids, right? So what happens when we increase temperature in solids? So we all know about kinetic energy and what happens when kinetic energy increases. The particles start vibrating at a faster pace, and also the force of attraction becomes a little lesser in its force. So basically, whenever there is a hike in the temperature, the particles will start vibrating, the kinetic energy increases, which leads to a downfall in the force of attraction. And ultimately, when there is a lot of temperature, the kinetic energy keeps on increasing, there reaches a point when the force of attraction is almost broken between the bonds of these particles, which converts the solid into liquid form. Because the bond is broken, the force of attraction is loosened, the solid particles are no longer connected with each other, so they tend to flow. So this temperature at which these particles of solids convert themselves into flowy form, liquid form, and the force of attraction is quite loose to allow them to flow, is known as the melting point. Right? So what is melting point exactly? The temperature at which solid melts to become a liquid at atmospheric pressure, normal environment pressure. For example, if I say melting point of ice का melting point क्या है? 273.16 Kelvin. Okay, so this is the temperature at which in kelvins when the ice would turn into water. Okay, and if I say that this is about the temperature, but what is this process happening here? When the solid is actually fusing or is melting into liquid, this process is called as fusion, the process of melting. The process of melting of a solid into liquid is called fusion. Okay, so I am repeating, the temperature at which, जब सिर्फ temperature के बारे में बात कर रहे हैं, उस particular temperature पे जिस पर solid liquid में convert हो जाएगा at atmospheric pressure, उसे हम melting point कहेंगे. This is related to temperature only. This process of conversion of solid into liquid, the process of melting of a solid into a liquid is called fusion. Right? Okay. अब मेल्टिंग प्रोसेस में एक बार जब सॉलिड अपने मेल्टिंग पॉइंट पे रीच कर जाता है, टेम्परेचर और फर्दर इंक्रीज नहीं होता है. होता क्या है, क्योंकि जब आप सॉलिड के पार्टिकल्स को व्हेन लेट्स लुक क्लोजली हियर, सो दीज आर द पार्टिकल्स ऑफ द सॉलिड, राइट? यू आर प्रोवाइडिंग हीट टू दीज पार्टिकल्स एंड यू आर प्रोवाइडिंग कंटिन्यूस हीट. टेम्परेचर में काफी इंक्रीज हो रहा है. It keeps on entering into the solid spaces. So वो क्या रहा है, the particles are vibrating, they are moving from their own places, force of attraction loosen up हो रहा है. So ultimately point ऐसा आता है जहाँ पे heat जो है वो बढ़ती नहीं है solid के अंदर, it doesn't increase to that much of a level. Why is that? ये just जितनी भी heat absorb करी जा रही है, that is being used up to break the force of attraction, so that melting can happen, right? The heat energy present in the solid at the time of melting is used by the particles to diminish the force of attraction between each other. So ये heat somehow we can say is hidden. हमें पता ही नहीं पड़ रहा कि ये हीट कहाँ जा रही है, बट एक्चुअली वो हीट अपने फोर्स ऑफ अट्रैक्शन को ब्रेक अप करने में यूज अप हो रही है. सो दिस काइंड ऑफ हिडन हीट इज कॉल्ड एज latent heat, the heat energy which is used to break the force of attraction between the particles of matter. This is known as latent heat. अब latent heat यहाँ पे हम किसके terms में यूज कर रहे हैं, अभी हमने देखा, it is used in terms of fusion because solid melt हो रहा है into liquid form. So latent heat of fusion, that's what we're learning here. The amount of heat energy required. So ये latent heat is basically amount of heat energy required to change 1 kg of a solid into liquid. Change 1 kg of a solid into liquid at normal atmospheric pressure at its melting point. And what is atmospheric pressure? That the word I'm using constantly. Atmospheric pressure is the pressure exerted by the weight of the atmosphere. Weight of atmosphere. It's pressure that it is exerting. Okay. So this was about the first case, increasing temperature in solids. Whenever we increase the temperature, kinetic energy increases, the force of attraction breaks loose, and so the solid converts into liquid. So the temperature at which the solid is being converted into liquid is called its melting point. We've seen an example of ice, 273.16 Kelvin. This process of entire thing, the process of melting of a solid into liquid, is known as fusion. But also the heat that is being used up is generally not seen after some point of time. So where is the heat going? Actually, it's somewhat termed as hidden. So in scientific terms, we name it as latent heat. And since we are learning about fusion here, so this would be known as latent heat of fusion. What is latent heat of fusion? Amount of heat energy required to change 1 kg of a solid into liquid at atmospheric pressure. What is atmospheric pressure? Pressure exerted by the weight of the atmosphere. Right? Okay. So now we will be learning about the second state of matter. What happens in liquids when we increase the temperature? Right? So similarly, solids में जैसा हुआ था, kinetic energy बढ़ेगी, temperature बढ़ रहा है तो kinetic energy भी बढ़ेगी, and particles की movement बढ़ जाएगी, उनकी vibration बढ़ जाएगी, उनका flow बढ़ जाएगा, and ultimately force of attraction will break loose. Right? So as we keep on supplying the heat, एक point ऐसा आएगा जब force of attraction का सारा जो power है या पूरा का पूरा force of attraction will be overcome completely. So that is the point when the liquid starts changing into gas form. Right? So जैसे हमने पहले कहा था, solids में similarly it happens in liquids as well. There will be a point where the liquid converts into gas. That point, in terms of temperature, will be called as boiling point. So what is boiling point? The temperature at which a liquid starts boiling at the atmospheric pressure is known as its boiling point. Boiling point of water, because we have to take liquid form, right? Boiling point of water is 373 Kelvin. Okay. So and similarly, this process, इस पूरे process को हम क्या कहेंगे? हमने पहले fusion कहा था. This process is obviously vaporization. And जैसे हमने लेटेंट हीट देखा था, यहाँ पर भी लेटेंट हीट होगा, राइट, ऑब्वियसली। बट यहाँ पे लेटेंट हीट किसकी टर्म्स में होगा? लेटेंट हीट ऑफ वेपराइजेशन, बिकॉज प्रोसेस यहाँ पे क्या हो रहा है? वेपराइजेशन का प्रोसेस हो रहा है, लिक्विड गैस में कन्वर्ट हो रहा है, दैट इज अ लेटेंट हीट ऑफ वेपराइजेशन। नाउ व्हाट इज लेटेंट हीट ऑफ वेपराइजेशन? amount of heat energy amount of heat energy required to change 1 kg of liquid into gas at atmospheric pressure, right? This is what is known as latent heat of vaporization. So let's look at it closely. Okay. So liquids में whenever we increase kinetic energy, force of attraction break up होना शुरू हो जाएगा. There will be a point when there is no force of attraction or very less force of attraction. That is the point or temperature where the liquid starts converting into gas. That point and temperature terms we call it as boiling point, right? So what is boiling point? The temperature at which a liquid starts boiling at the atmospheric pressure is known as boiling point. We saw an example of water. So water's boiling point is 373 Kelvin. So this process will be vaporization because liquid is converted into gaseous form, and the latent heat of vaporization will be learnt here. The hidden heat, the latent heat of vaporization, and what is it? Amount of heat energy required to change 1 kg of liquid into gas at atmospheric pressure. Okay. Now we are on to the case 2 now. Shift the page forward. Case 2. This is about decreasing temperature. Okay. So what happens when we decrease the temperature? Let's go reverse way. We're going to first begin with gases. Okay. Now tell me, when we are decreasing the temperature, what will happen to kinetic energy? Will it increase or decrease? Obviously, kinetic energy कम होती जाएगी. Movement ही कम हो रहा है उनको. They are not being pushed forward. तो particles जिस flow में थे वो उतने ही flow में है. Imagining कि आपने temperature बढ़ाया है तो particles की speed बढ़ गई है. But अगर आप उसी particles को fridge में रख दोगे या you keep them somewhere colder या temperature आप उनका gas बंद कर रहे हैं, for example. So what is happening? The movement, the external source of energy has been stopped. So eventually the pace will slow down. The particles will not move at as much of a speed as they were moving earlier. Unki speed hai. They're still moving around, but their movement is slower. So kinetic energy also will come down. The kinetic energy has come down now. What will happen to the force of attraction? Obviously, there will be an increase in force of attraction, because of which the particles now have started to come closer to each other. Not that they're attracted, obviously. Force lag raha hai unki taraf कि they should move towards each other. The particles who were way far away from each other are now coming a little closer to each other. Okay. So since they are coming closer to each other, we would call it as condensation, or we may also call it as liquefaction, right? Condensation or liquefaction is the same process that happens in formation of clouds as well. We've been learning about this in our earlier classes as well in the water cycle. So this is what is condensation or liquefaction is happening. So what is it in terms of definition? The process of converting a gas into liquid by cooling down its temperature, right? And the example could be about clouds formation, right? Okay. So now the next state that we are going to take is about liquids. What's happening in liquids? Obviously, similarly as we learned earlier, there's a different kinetic energy, right? Because of which there's a heightened force of attraction. Particles are coming close to each other, and liquid is getting converted into solid. This is called as solidification. Solidification का क्या example हो सकता है? Water to ice, simple, right? You're just increasing the temperature. Oh, sorry, you're decreasing the temperature, and because of which, what is happening? The particles are bound to come close to each other and stay in their own position. Majorly, there is kinetic energy, but then that is very, very, very less, right? This is called solidification. And also, if I want to learn about gas to solid form directly, so this is what is called as sublimation. ऐसा भी possible है कि gas without going through the second phase, which is the liquid phase, directly converts into solid phase. So what is it? Basically, change of state of a gas directly into solid and vice versa is known as sublimation. इसका एक example that we can look out is camphor. Camphor क्या है? Solid है, right? When you burn it, it directly evaporates into air without changing into liquid. Therefore, by increasing or decreasing the temperature, we can change the states of matter into other, right? So, states of matter and their interchangeability. So here we have solid, liquid, and gas. Now, solid to liquid, what do we call it as? Melting. Liquid to gas, vaporization. Now if I want to go reverse, condensation, right? And liquid to solid form, freezing or solidification. And what will I call this process as? Solid directly to gas or gas directly to solid? Sublimation. Right? Learn this diagram, it's quite easy. When you understand it, it will be easy for you to understand. Okay. So these were the three different states of matter and their interchangeability based on temperature. Okay. Next thing that we're learning here is about effect of pressure. Because we're using atmospheric pressure and what happens at normal temperature, normal pressure. So let's understand कि pressure की वजह से क्या होता है. जब हम pressure apply करते हैं, we can bring the particles of matter close to each other. हम particles के matter को एक दूसरे के साथ ज़्यादा ला सकते हैं ताकि उनके बीच का जो force of attraction है वो बढ़ सके. Just to bring the particles close together, space को हम कम करना चाहते हैं, particles को पास लाना चाहते हैं. In that case, we have to apply pressure. So pressure apply करने से क्या होगा? जितना भी matter है वो compress हो सकता है. And सबसे ज़्यादा important ये कहाँ पे आता है? कहाँ पे आता है? Gas को compress करने में काम होता है. तो gas बहुत varied and for a larger distance फैली होती है. We want to compress it into a smaller space. We have to apply a lot of pressure so that the space between it can be reduced and the force of attraction can be increased so that the particles come close to each other, and that is how the gas can be changed into liquid. This is another way that the gaseous particles can convert into liquid particles. So इसका सबसे अच्छा example हम देखते हैं dry ice. Dry ice है क्या? कार्बन डाइऑक्साइड जब solid form में होती है, so that is when it is called as dry ice, right? तो हुआ क्या है? Actually वो gaseous form में था, right? अगर हमने उसका temperature भी decrease कर दिया, हमने उसमें बहुत high pressure लगाया है, या basically हम ये कह सकते हैं 1 atmosphere, 1 atmospheric pressure can convert gaseous CO2 into solid CO2, which is basically dry ice, right? So our next topic is about evaporation. It's quite easy, but I just want to elaborate on the difference between evaporation and boiling, right? A lot of students confuse it together. So evaporation, we understand one thing, that the particles में पता है they are never at rest. प्लस हर पार्टिकल की अपनी ही एक एनर्जी होगी, किसी की हाई होगी, किसी की कम होगी, किसी की मीडियम होगी. So the ones with higher energy, they're going to leave the water surface, right? जो भी सबसे टॉप पे होंगे, obviously उनको ज्यादा एक्सपोजर है, they are going to bubble out and move away. They're going to fly up into the atmosphere. But boiling में क्या हो रहा है? The bubbles are being formed. They have a medium energy. They're just moving around the same space of water. They're just crashing into one another, maybe onto the surface of the container. They're crashing and coming back. Let's look at it in the pictorial form. So I have one container which has water in it, right? And again I have another container. And again I have water in both the containers. Okay. By the way, these are same amounts. This one is a little bigger. Anyway, so this is talking about evaporation and this one is talking about boiling. Okay. अब evaporation में हो क्या रहा है? Right? Understand one thing. The pressure that has been applied here, red pen, the pressure that has been applied here is less than the atmospheric pressure. Because of which bubbles बनते ही नहीं है. जो फर्स्ट लेयर है इनकी water particles की, they just leave the surface and they go up as vapors. But here what is happening? The vapor pressure or the pressure here is equal to atmospheric pressure. So what is happening? The bubbles here are formed, no doubt, and they are moving and crashing into one another. They're just moving around, crashing into one another. Definitely they are coming on the surface also, but their pressure is equaling the atmospheric pressure. So कोई difference ही नहीं है इनके pressure में. So there is no point, there is no reason for these particles to leave. But here वो क्या रहा है? जो हम pressure लगा रहे हैं या जो temperature के high की वजह से kinetic energy की वजह से जो pressure particles के बीच में जो extend हो रहा है, that is much more higher, which is allowing the particles to overcome and hence move out of the container, right? अब बहुत सारे अलग अलग फैक्टर्स होते हैं. सो अब इवेपोरेशन की वजह से देयर इज कूलिंग एज वेल, राइट? क्यों कूलिंग हो रही है? इवेपोरेशन की प्रोसेस में पार्टिकल्स एनर्जी कंज्यूम कर रहे हैं. यू सीन हियर particles energy consume करते हैं, then they take away that energy. Because of the energy only they are vibrating more and they are moving out of the situation. So basically particles जब अपनी जगह छोड़ रहे हैं, so they need energy to absorb, right? So that they can actually leave the surface of water. When they are absorbing energy while leaving from the surrounding, just to compensate the energy that is being lost in the process of evaporation, that is why cooling happens. So let us understand this again. I have a container, I have water, right? And instead of this, I'm going to make some particles. Some particles that are about. So leveling and understanding this level. I have 3 levels here. This one is high energy level, this is medium energy level, and this is low energy level. So in the high energy level, what is happening? Basically, the particles are leaving the container. क्योंकि एनर्जी ज़्यादा, they are evaporating. इस एरिया में क्या है? मीडियम एनर्जी है, because of which they are just in the container. They remain here itself. They don't go anywhere. And this area, which has lower energy, they are being pulled more over towards the downward. They are moving, but they have been pulled down, right? So, these particles, let us look at the area of higher energy. What is happening here? These particles will definitely require a lot of energy to leave the surface of the water. So, ये energy in इस area से आ रही है. So, while they are leaving, they still require a lot of energy so that they can keep floating, they can keep moving up, so that they can keep rising. So this energy is coming from where? This is coming from the surrounding, and that is why the surrounding becomes cool, because the surrounding is losing its heat energy. So one practical example could be that whenever we wear cotton clothes in summer, cotton clothes, what happens then? We feel comparatively comfortable whenever we are sweating. So what is happening? Surface, हमारी body के surface से whenever we are perspiring, हमारी body में से sweat निकल रहा है, वो evaporate होता है. Evaporate होते ही जो molecules हैं वो अपने साथ में सारी energy of the body उस area की particularly they take away with them and keeps our body cool. And since we have a cotton cloth upon us, so that is been absorbed, the sweat is been absorbed easily and directly and exposes it directly to the atmosphere. And because of which the evaporation is faster. कॉटन क्या कर रहा है? हमारे स्वेट को ऑब्जॉर्ब कर रहा है, उसे एटमॉस्फेयर को एक्सपोज कर रहा है, बिकॉज वो टेम्परेचर क्विकली से ले लेता है एंड देन द कूलिंग ऑफ आवर बॉडी हैपेंस, राइट? हम अपने हाथ पे नेल पेंट रिमूवर, इफ वी try to pour some nail paint remover on our hand, we feel that area is quite cool. Our palms feel cooler. Why? Because the particles that are evaporating from our surface are getting the energy to evaporate from our body, from the surface of our hand, from the palm of our hand. And that is the only reason that we feel cooler when acetone is poured onto our hand and when it is evaporated, right? So happily we have completed our entire chapter of matter in our surroundings, the first chapter of 9th standard. And any questions, any queries, please do write in the comment section below. Also do like, share and subscribe the channel. Thank you.